tick-tock, the clock counts away. Jeranism is about to improve your day. That's what he do when he performing at the highest. You'll be telling all your friends about how he is the flyest. Get hype, get up, time to learn something new. 5 minutes left, so do what you gotta do. Grab a drink, text a homie, smash the like, share the show. It's almost time that he goes live from the studio. Ooh, you feel that energy rising? Nothing but the truth, we are never compromising. Open your mind, let's take a ride. Jaren's almost here and the crowd's electrified. Lights down low, crowd tuned in. Truth unlocked, let the show begin. Red pill taker, no faker, no shield. Jaren ain't no sellout, he always keeping it real. What's fact if that was black, it was fake out the gate. Close a fact, I went back, now I gotta shake the hate. Bad research by bad guys with bad intentions, filled with lies. You can tell the shape of the ground, just look up in the sky. Always honest and sometimes right. He's seen the lies and he fought the fight. Now he's on a mission here to flip the game. While he's been growing, y'all remaining the same. Looking for the best, you got the place right. Home court advantage for Mr. Friday Night. Always push forward, leave the lies behind. Dig a little deeper and see what you can find. He's been around, he's seen it all. 10 years of flat back to that ball. Share the show, smash the like. Ooh, Jaren's on tonight. Ooh, open up your eyes. Pay attention to the size. Earth's too big to see the curve. Eyes up here, you got some nerve. What's fact, but that was black, it was fake out the gate. Close a fact, I went back, now I gotta shake the hate. Bad research by bad guys with bad intentions, filled with lies. You can tell the shape of the ground, just look up in the sky. Grab your drink, take a seat, let one knuckle to this beat. You will laugh, you will cry to find the truth, expose the lies. It's not fact, now it's clear, he was wrong for hella years. He just could not come to grips with living on the spear. Secret tricks, I ain't blind, truth over hype, I stay prime. Think for myself, don't cosign, do what's right, never fall in line. Skeptic minded, I break through, no brainwash, just straight truth. Fast talk, don't make facts real, show receipts, so there's no deal. So buckle up, buckle in, the show is about to begin. Time to face facts, you know the earth, it ain't flat. Once you go flat, only the cool go back. What's fact, if that was black, it was fake out the gate. Close the fact, I went back, now I gotta shake the hate. Bad research by bad guys with bad intentions, filled with lies. You can tell the shape of the ground, just look up in the sky. He's a man who admits his mistakes. The mother little boy just saying T if he was fake. Waiting on the man, myth, legend, and host of the show. The show's about to start. 4, 4, 3, 2, 1, go!
Yeah. 20 on the shot clock, hold on, don't start. Snack stash deep, hit the fridge, hit the cart. Popcorn popping, microwave sound singing. Phone buzz, loud group chat still pinging. Wait for it, 2 minutes just a flash. Grab a drink, text your boo, make it fast. Blowing O's, chill vibes as they flow. Spread the word, share the show, let them know. Skip the ads, let it breathe, let it marinate. Time's quick, no trick, don't overcomplicate. Couch dip low like sitting in quicksand. Showtime soon, countdown in hand. Clock ticks, you can almost taste the beat. Feet up, zoned out, time sheet delete. Living in the pause, it's the in-between. Scene setter making moves with the routine. Wait for it, 2 minutes just a flash. Grab a drink, text your boo, make it fast. Blowing O's, chill vibes as they flow. Spread the word, share the show, let them know. Break's almost done, clock reels us back. Snacks in hand, energy intact. Hit the playlist, seat warm like a throne. Show locked in, it's yours all alone.
Guys ready? Got a good one for you. It is the Jeranism Show. Welcome, everybody. We got a fun one for you. Making sure everything's working here. We've got optical measurements of Earth curve and understanding refraction. We've got a presentation by Jesse Gordon coming up here shortly. and should be a good one. Let me see if he's here. Jesse, how are you, my friend?
Oh, I am well. Thank you, sir. And how are you?
Excellent, excellent. Just making sure that our interview screen is right, and it is not for some reason. All right, well, we got to fix this. All right, we're going to be on the little screen for now because I don't know why the big screen's not working. This will work for now. Just tell everybody who you are, and then we'll get into something quickly before your presentation. But go ahead and tell people who you are in case they don't know where they can find you and all that stuff.
Oh, I don't know. I don't even know where to find myself.
Well,
but
you're not very helpful.
But my name is Jesse, and in December of 2018, I had no idea that anyone even believed that the Earth was flat. It just wasn't even part of my awareness. And a real life friend of mine said, "Hey, Jesse, you know, NASA's fake and the Earth is flat." And I was like, haha, funny. He's like, "No, I'm serious. Check into it. Go watch Sargent." He said, "Go put Sargent into YouTube."
Mm-hmm.
So that was how it started for me. And since then, I've been doing whatever measurements and observations I can.
All right. Well, and what have you found? What do you think? We're going to look at real quick. Let's look at the poll question that I asked, and then I'll ask you that question. So the poll question was, let me bring it up. Hello, everybody in the chat. It was, do we measure Earth curve, or is what flat earthers say true, that we always measure Earth flat? So let's look at the percentages. We've got 50% of people said we certainly measure Earth curve. 39% of people says we have never measured Earth curve. And 11% of people are undecided, and so they will watch the show. So you tell me, Jesse, do we measure Earth curve?
Well, I don't know who all includes we, but I sure have measured Earth curve.
Well, me, I guess in general. So you disagree then with the statement that we do not measure Earth curve and we measure Earth flat?
I would disagree.
Okay. And what would you think? Most surveyors, most people in the industry would disagree with that as well?
Yes.
Okay. So we'll find out why that is. Let me just get this real quick on here. I want to fix our screen, which now probably doesn't matter because we won't need it again. There, see, now it's fixed. Now we are on a larger screen. All right, so that is the poll question. Thank you guys for joining in that. We've got, I would join myself in the we measure Earth curve. Once I understood that the Earth is curved, then the zenith angles, reciprocal zenith angles made sense to me. And so we are going to cover that momentarily. But I want to cover something first because if people have not seen, we're going to watch a real quick opening part of this video. Steve Falconer, who is the channel owner at Spacebusters, who I used to consider was a good guy, thought he was a good researcher. He ends up not being a good guy or a good researcher. Imagine that. So one funny thing I've seen is that I've had at least 20 people come to me today. Like, what are you afraid to answer Steve Falconer? Why don't you look at his stuff? And I'm like laughing because his first one was so bad. And so I was like, oh man, he must have been equally bad in the second one. And he was. And in fact, he actually proves the Earth curves in his video. And so I want to show you that and get it out of the way. And Steve, you need to do a little bit more research and stop acting so cocky because you're about to see what happens when you do that, how ridiculous you look. And here's what Steve did. He went after the low-hanging fruit. And what I mean by that is everybody in the Flat Earth community hates Jaron right now, right? So what people do is they make a video, say how much they hate Jaron, say my name a bunch in the video, and they get a bunch of kudos for it because that's the general sentiment in the community right now. So I'm going to show you why that exposes you guys, Flat Earthers, and the creators as being just terrible researchers. It means everybody who watched his video, nobody followed it up, or else you would see the same thing I'm about to show you. But let's start with this video, and we're just going to watch a few minutes of it. And we know you reserve all rights you reserve, or whatever. Here it comes.
All rights reserved. We reserve all rights.
Let's just get his, see what he's trying to get across there.
Houston, you're going to want to stick around for the ending finale of this film because you definitely have a major problem now. But first, one last time.
Let me just interject here. They don't have a problem. It's Steve who doesn't understand things and can't follow how the globe works. And he's about to expose the Flat Earth right here for being nonsense.
And for those still not getting it, there is Vernadsky Base right there on the sea level. See the water? There is Rothera Station right there on the sea level. See the water? No altitude.
Notice how he's being real condescending and real like funny. It's just because the only people watching this video are Flat Earthers. So he can say that kind of stuff and you guys just all think it means he knows what he's talking about. And he doesn't. And we're going to show you. So he's talking about Vernadsky and Rothera, the two research stations. He then goes into some, basically reminding you that which way the direction the sun goes.
Difference between them to affect any sunrise or sunset times. It's called sea level because water doesn't magically curve around balls.
Yeah,
like everywhere else on Earth, the sun rises in the east and sets in the west in Antarctica. It's no different for these two Vernadsky.
So just showing you, he's showing you here that Vernadsky is more east than the one here on the left, Rothera, which is more west. So he can't understand how the sun rises for the one on the left first. And then he goes into a whole thing about talking how funny it would be for the sun to rise in the west, how it never rises in the west, and this means that this is impossible on a globe. But he just doesn't know how the globe works. I've already told him this in his last video. He still doesn't get it. Let me show you. He has to draw this little flashlight going by and says, no, it has to hit Vernadsky first. Notice what the map that he's using here is the flat Earth map. So he's exposing the fact that if the Earth were flat, then he's absolutely right. Vernadsky would have the sun first and Rothera second, but the Earth is not flat, and therefore it's a ball. And when we go put it on a ball, what do you know? We're going to see that Rothera rises first. Why is that? How? It doesn't rise in the west, Sharon. How is that? You just need to know how the globe works. Steve doesn't know that. Steve wants to say my name 50 times in his video and act like he has some big gotcha, and you'll see that he doesn't. Let me show you. So he then talks about how ridiculous it would be to say that the sun rises in Chicago before it rises rises in LA before Chicago. Just ridiculous. This would not be impacted by the Earth being a globe. Let's look at here. So I put two stations. This is Google Earth. You'll notice that we've got here Rothera, and up here a little bit north, we've got this one, which is called Vernadsky. Right away, anybody who knows the globe is going to notice something peculiar about these two places. How about the fact that one of them is within the Arctic Circle, one of them is without? So right away, I can just know by looking at this, oh, well, this place gets 24 hours of sun, and this place does not. Does this place get it all winter or all summer? No, of course not, because it's close to that line. It means it's just going to get a couple days. And then this one here, you're not going to ever get it. Why is that? Because this is the demarcation line, the 66 degrees south latitude. So let's continue on, and I'm going to show you. I'm just going to move in here. We're going to take this guy right here. We're going to turn around and look at the east. Now, he says that the sun always rises in the east. Is that true? Or does the sun sometimes rise in the southeast? Let's get down here. We're now at about base level here at, which one is that? I forgot, right there, I think. So if we go here and we're going to go to a date that he has in his video of November 27th. So I'm bringing up the sun, going to November. Here we go. We'll get all the way to November. Okay, we're right about November 22nd there. And now we're going to go here. Okay, so that's 22nd. Let's get a little bit further. You really could fix the way that this works here. Oops. 11/26. There we go. All right. So now what we're looking at is the 26th. We are down here at the station. We are going to be looking for sunrise. Okay. And let's see here. Up here. Okay. And we're going to pull this one forward to here. Okay. So now I cannot believe I just did that. Sorry, I went back to the same date again in March. Let's go to November. Okay, just give me a second. That's May, June, come on, July, August, September, October, November. Okay, we're November 18th, 19th, 20, 28, 29. Okay, there we go. Now you'll notice that it's light out the whole time. Why is that? Why is it only dark for a second? Let's get down here even more. And you'll notice that if we look to the southeast, you'll notice that the sun, there's the sun. Okay, let's turn a little bit more. It looks like it's almost rising almost south. And you'll notice that it just kind of swings right there, right by. So there it's dark and it pops up. Okay, so you're talking about barely occulting the sun. See there? You wouldn't even be able to tell, is this a real sunrise? Is it not? Is the middle of the sun blocked? We don't know. But certainly this is going to have sun before. Let's go look up here. And this is how easy it is just to figure this out. And Steve can't do it. He has to make a whole video and pretend like he's debunked something and then have a bunch of people come and contact me like I am afraid to answer his stupid debunk, which isn't a debunk. He should be smart enough to realize, oh, I'm inside the Arctic Circle here and I'm outside here. So therefore, when I get down here, what's going to happen? The sun is going to set. So notice that the sun is now set. What does that mean? Which one do you think got the sun first? Which one got the sun first? The one that's set or the one that's above the horizon. So what do you know? A place both south and west of the other location gets the sun first. Steve, congratulations on proving that the Earth is a sphere. Keep going, my friend. You also proved that everywhere, all those bases in Antarctica all got 24 hours of sun. So what are you doing? Whose team do you work for? Because you're just clueless. How do you not figure this out on your own? Have you not looked into this for 2 weeks, 3 weeks? You're a fool. Go hang out with your best friend, Alex Michael, and you guys can be fools together. So look at, again, we just looked. These two places, one is more east than the other. This one gets the sun first. Why? Steve's too stupid. He thinks that the sun rises in the east every day. It does not. It rises in the southeast, and this place is more south and gets the sun first than this place. End of story. Debunked. Way to go, Steve. Way to go! You did it. You did a good job, Steve. You did a good job proving the globe for us. All right, now we got Jesse coming up with his presentation. Jesse, go right ahead. It's all you. I'm going to get my map off the screen. And
all right, am I coming through good?
You are good.
All right, so this is a simultaneous reciprocal zenith angle measurement that I just wanted to throw in at the beginning because it's the first time I've ever done that.
Oh, by the way, did you want me to play your video yet, or you're going to tell me when?
Oh, yeah, go for it. I'm sorry, I forgot.
Okay, we're going to play this video real quick, and then
I told you I couldn't find myself, even.
Yes, that's true. I forgot about this, and then I don't know why that screen is not working well either. All right, we're just going to play it, even though it's not maybe wide. That's better. Here we go.
Well, here I am up in the mountains. It's very beautiful. Doing a simultaneous reciprocal zenith angle to that little hump beyond the hump there. It's 7.2 miles, I think.
All right, where was that, by the way?
That was up above Port Angeles, Washington, USA, in the Hurricane Ridge area, specifically on the ridge along the Obstruction Point Road, which is a little gravel road that goes out to another peak named Obstruction Point. But I had found, and the GPS coordinates are actually right here on my screen.
Okay.
Is this my mouse show?
Yep, we see it.
Okay. Oh, good. So there's the GPS coordinates if anyone wants to check it out on Google Earth. It's up in the Olympic Peninsula mountain ranges, and it's super beautiful up there. It's snowed in right now, so I did this last year. I got to wait till next year. And then the other end point was here on Blue Mountain, above Port Angeles. Obviously, I say that because there's probably 1,000 Blue Mountains in the United States alone. So anyway, I had found these two locations. Well, I'd been to the Blue Mountain one a lot. It's a super popular tourist location. But I looked on Google Earth for a place that had 2 points that were of equal elevation and had line of sight. And so I thought I found a spot on this ridge over here, 7.2 miles away. It looked good on Google Earth. So just as a kind of a last minute thing, my brother and I ran up there last year just before the weather went too bad and checked it out. And it was, in fact, line of sight. So you can see the elevation profile. We were both at the same height here. There was an intervening mountain that wasn't quite as tall. That's what that other ridge was. But when I says the hump beyond the hump, that was the hump in the middle. And so, but you can see the line of sight was high above the surface for the most of it. So that gives it a much better chance of being a consistent elevation angle reading. So there's the top-down view, and it's 7.19 miles. And the cool thing about these two locations is you can drive almost to each of them, and then it's just like a 5 or 10 minute walk up to the peak from there. So the access is good. So here's the vantage point from my end. Here's my theodolite with a flashlight set on top. We had flashlights and lasers to help each other see each other, because 7 miles is kind of a long ways to see someone standing there. He was standing right under that red arrow, which I can zoom in on a bit. And there's just another shot of my setup. later I put a little laser that sticks on under here on the lens that helped me aim it at him. There's his view of my laser from 7.2 miles, and it's just a 5 milliwatt laser. And this was a full sunny day, so lasers are amazing. This was just like a cat toy grade laser, and because it was pointed straight at the camera, it was visible even in the brightest of conditions. A little closer on that. All right, here's my measurement, face left. The V is the vertical elevation angle, degrees, 2 minutes, 0 degrees, 2 minutes, 27 seconds negative, so down tilt. Through the scope, notice the H is on the left. Now here's my face right, negative 246. With a theodolite, you always do a face left, face right, and then you average the two readings because that offsets any vertical index error you may have in the instrument. And notice the H on the right. This is through the scope on the face right. And here is the readings from my brother's end. So here's his face right, it looks like. Through the scope. Face left. Through the scope. And at that point, I was using the flashlight, which you can almost see, but not very well. It was really just a test run. We planned to do it again, but do it much better. This was really just the goal was to get up there and see, are these two sites accessible and line of sight? And we thought, well, we might as well do a little bit of testing since we were at it. So that's what this is. He placed his theodolite over a brass survey marker up there at 6,000 whatever foot elevation, and that was placed in 1955, it looks like. All right, so the conclusion of this is I took and I averaged the face left, face right reading that I got. Negative 2 degrees, 36 and a half arc minutes, or 2 minutes and 36 arc seconds. And I averaged the face right and face left he got, and he got the same thing. So, and that is very close to the globe prediction if you account for refraction, and it sure doesn't match flat Earth, because if light was straight...
All rights reserved.
Sorry. Oh, that's playing. Sorry.
If light was straight, and we're both at the same elevation, and we're clearly at the same elevation because we measured the same elevation angle to each other, you know, if one of us was higher, the other would have been looking upward at him, and, you know, it's like... You know, if it's not level, you're going to be one's looking up and the other's looking down. But we were both looking at the same angle, so we had to have been at the same elevation. So if Earth was flat, then a straight line between those two equal elevation points would have been level. It would not have been tilting down 2 minutes 33 arc seconds, or 236 each way. So that was that one. Do you have any questions, or shall I?
Nope, it's good so far.
Shall I move on to the next one here?
I guess in case anybody doesn't know exactly what you are measuring, you might want to mention that, but I think I got it.
Okay, well, it's a reciprocal zenith angle, and I will get into zenith angles and elevation angles in my next series here. But basically, we were measuring the elevation angle from this peak from the peak on the left over to the peak on the right, while at the same time measuring the elevation angle from the peak on the left over to the peak of the right. And I will get more into elevation angle measurements in the upcoming slides here. Just give me about 3 seconds to change my screen share. Can I do that? Change the window I'm sharing?
You should be able to. I don't know if it'll go away for a second or not, but it'll be fine.
I think... okay, do we got the mountain goat?
Yep, we got him.
I'm not much for memes, but this is a meme I made. I took the picture of the mountain goat, so I figured I was allowed.
You can make the meme. Go ahead.
All right. So this mountain goat is thinking, har, har, imagine thinking Earth is flat, and he's climbing all over these non-flat rocks.
It's very good. It's very good. I wouldn't release it too far, but it's okay.
Well, it's got the straw man elements of,
That's true.
you know, that every meme needs.
Yeah, they're all
right?
required. Yes.
Okay. All right. So this is about measurements of drop over distance using surveying equipment, mostly theodolites, but one amazing auto level. So this little chart shows the flat Earth prediction, which is the green line here, which is simply 0 deviation from flat, or 0 drop over distance, or 0 drop from the horizontal over distance. Some flat earthers have challenged me and said that I was straw manning them and that that's not what they predict. And I simply says, well, okay, tell me how much drop over distance, drop from the horizontal over distance do you expect, and I'll use that. And then they just never provided that. The red line is the globe prediction, including correction for refraction for measured drop over distance. And the blue dots are real world samples, measurements taken by myself, some professional surveyors like Jesse Kozlowski, and which he publishes on his website, and some people in Australia, and two, I call them anti-globers, because like Bev says he's not a flat earther, but he argues that all plumb lines are parallel, so that's kind of means flat earth. But anyway, they all agree, that Earth is not a globe, so I call them anti-globers. But anyway, so we've got one globe, 2 anti-globers, 3 continents represented in this data, and 4 United States states: Washington, Oregon, California, and New Jersey. And here's the data. So this red line is simply, I told Google Sheets to make a line that most closely matched the data. That's the line it gave. So if we zoom in, we can see I've got, and this spreadsheet is publicly available on my shared spreadsheet. So if anyone wants to go get the actual spreadsheet, we can post that in the chat later. And so we've got observer locations and targets and all the information there. And as you can see, the drop over distance does increase, and it does form a curve. So this is what we mean by measuring an angle. Let's say we have a tree of a given distance and a given height. That forms a geometric trigonometric relationship with the distance and the height and the angle. This is high school stuff, so most of you should be able to follow it no trouble. And the formula is very simple. If we know the rise and the run, we can calculate the elevation angle. If we know the angle and the run, we can calculate the rise. In other words, there's 3 variables, and all we have to know is 2 of them, and we can calculate the third. Whatever the one is that we don't know, we can use the other 2 to calculate it. So if we know that something is, say, 6 feet or 6 miles or 6 anything high, and 10 anything of the same anything away, so if this is 6 feet, then 10 feet, we can put rise divided by run, rise being the height, run being the distance.
Ruhif wants to know the formula for that line of best fit.
Oh, okay.
What does that? What does that mean? Line of best fit.
Well, that's the red line is the line of best fit.
Oh, gotcha.
And this is the formula that it came up with, right there. So I hope you can screenshot that, Ruhif.
Ruhif, there you go. You can screenshot that.
Sorry about the fuzzy pixels. I like them soft.
I don't know. It's so funny. The people in this chat still are just freaking out. If you just saw, I just showed you how Steve Falconer proved that the Earth's a sphere. So don't get so upset at me. Okay, it's quite a lot of people are doing that, and flat earthers do it all the time. They just don't realize it. That's the sad thing. Go ahead.
All right. So in this case, we can take the height 6 divided by the 10, the distance and then feed that into the arctangent function, and that gives us the angle of 31 degrees. Or if instead we know the distance, we can measure the angle of 31 degrees. We can feed the angle into the tangent function and multiply it times the run or the distance, and we get the rise or the height. So measuring that is a simple function of having some circular angle reference, like a protractor, that is referenced to level, and we simply measure the elevation angle to the top of whatever we're measuring. Make that a little bigger for those of you on small phone screens. You can see the level, and this is actually laying flat on my table, but it's representative of how a theodolite works. There's a vertical angle scale leveled by a bubble level, and then you read the elevation angle on that vertical scale, and you can see here's 30 degrees and 31. I have two of these, and I tell people that I have 270 degrees right on, or 720 degrees right on my desk. When they brag about their degrees, I got them up one. Okay, so to show that this formula is correct, you can test this at your own home. I have drawn here a 4-inch high line at a distance of 5 inches, and you can see the measured angle is 38.7 degrees. And when we take and do tangent of 38.7 degrees and multiply it times the distance of 5, it equals 4.0. Now I've moved the line to 10 inches away, but it's still 4 inches tall physically. We measure the angle to be 21.2 degrees, or 21.8 degrees. And you can see the formula still works. We do tangent of the angle, 21.8 degrees, times 10, which is the new distance. Again, it equals 4. So the question is often posed to me, well, are you accounting for perspective drop? And the answer is yes. And the way that works is, when something is twice as far, the slope will be half as much because it appears lower if it's above you.
Is that always, or does that break down when you get closer or far? Would it always be half, or would it be that if you went half again and half again, eventually it would stop working, that formula?
Like, does it approach to 90 degrees, straight up?
Well, I just thought that when you're doing angular size and things like that, that it works well in the middle form, but not when you're very close to an item or when you're very far from an item. Then it doesn't go by that rule. But I guess if you don't know it, that's fine. I was just wondering.
Yeah, no, this works all the way up to 90 degrees, all the way up to overhead.
Okay, got you.
Because the slope becomes basically infinite at that point, but it still works.
Right. So, but perspective, because I've heard people say that for instance, the stars are answered by perspective, which I don't think that works, because I don't think perspective has a linear movement like that. But you're saying it does?
Once you feed it through tangent, it does.
Okay, when you feed it through tangent, got you.
Yeah. Right. So look here at the top. Tangent of 38.7 is 0.8 degrees.
Okay.
Or is 0.8, a slope.
Gotcha.
Which means the slope is, how many feet it goes up per foot that it goes to the right, for example. 21.8 degrees into tangent gives a slope that it is, in fact, exactly half of that. So
Okay.
it's exactly twice as far, and the slope is exactly half. So it is perfect. It's dead on.
Okay.
So when the distance is twice as far, the slope is half as much. But because we're multiplying it times the distance, the slope is half as much, but the distance is twice as much. So that's like dividing by 2 and then multiplying by 2. There's no, it works out. Because if you double something and then have something, you end up with what you started with, right?
Gotcha.
So because the formula multiplies times the distance, that perfectly compensates for the reduction in slope due to distance. And so you can see this formula works perfectly.
Okay.
All right, so I have many measurements, and they're a lot of fun, but this presentation is going to concentrate on this little cluster of them here at 75 miles because I took those from my old home where I could do them frequently without having to drive anywhere. So I have 36 measurements, all from the same location to the same location, which gives me an idea of what my deviation is going to be. And you can see that this dot is a little bit stretched vertically because there is some day-to-day or hour-to-hour deviation in the measurements. Because someone, oftentimes if I present just a single measurement, the counter argument will be, well, there was a weird weather condition that day, or your instrument wasn't working, or something just happened to cause it to match a globe, right? So I did 36 measurements. I did not throw out any outliers, and those are what I want to look at next. But first, I will show you my setup. Here I was at home, 181 feet above sea level, and according to the rise over run formula that we just went over, I should have measured 1.53 degrees. That's the expected angle if Earth was flat. What I really measured was 1.07 degrees, which is quite a lot. That's a huge difference. These instruments I'm using are capable of measuring, a thousandth of a degree easily. So this is a huge difference. And so here's 75 miles is our run. The mountain is 10,600 feet higher than me, so that's our rise. Never mind the guy fishing. He hasn't got a license anyway.
Arrest him.
Well, he's hooked on the bottom anyway, so it doesn't matter. All right, so this is the data from my 36 measurements. And you can see here, so 0 is at the top, and then they all show missing height. This is the 3,000 foot mark here. Every one of them showed at least 3,090 feet missing. And some of them showed up to like 3,280 feet missing or something. So yes, there was variation with weather, but it was not nearly enough to explain this on a flat Earth. If Earth had been flat, then these measurements should have been kind of centered around the 0 line up at the top. Some a little bit above, some a little bit below, but kind of around the 0 line. But for some reason, every single one of them was more than 3,000 feet missing height. And I didn't just use one instrument because it could be said that maybe the instrument I was using was not functioning correctly. I used 11 different instruments, and their color codes are shown over here on the right. So you can see I used most of them for this one instrument, but then I also threw in all the others too. So I'm pretty confident that it was not instrument error, and I'm highly confident that it was not a freak weather incident, because otherwise it wouldn't have done the same thing 36 times in a row. And I didn't throw out any. I kept all measurements, even the ones that didn't match the globe, even the ones that were kind of high or kind of low. Like you can see right here, this one was favoring flat Earth a little bit. I mean, it's still more than 3,000 feet missing, but it wasn't down where the globe expected it exactly. But I kept them all, and they just don't work on a flat Earth. They are not exactly what the globe predicts, because I was not correcting for refraction. However, refraction would cause a 556 foot difference in height. And if we add that to our 3,000 and our average of 3,200 missing feet, so like here's our average of all our measurements. The average was about 3,200 missing feet. And if we add the 556 feet predicted by the surveying standard refraction. Then we get 3759, which is 9 feet different from the globe prediction. So my question to flat earthers is, if the Earth is flat, how did I possibly get all of these measurements, including the outliers, that all average together match the globe model so closely at 75 miles once the globe's standard atmospheric refraction of 556 feet is added? Okay. Did you have any questions about that? Because it shifts a little bit.
No, I think it's good. I was trying to answer for flat earthers. They would just say that the refraction number is made up, that it's something that's just added to make up for what we can see due to perspective. That's their answer.
Yeah. It's only 556 feet. I'll throw that out for the sake of discussion. There's still 3,200 missing.
Right.
It's still a globe. This would be slightly bigger.
Well, I think that people need to recognize that, geometrically speaking, if you're talking about on paper, yeah, that's where on paper you would run out of the ability to see. But we know there's an atmosphere, and we know that the atmosphere causes optical effects, one of those being that it can magnify things, it can bring things back from behind corners. We've seen that in a melodome's example. So it's time to give up the refraction isn't real argument because it's ridiculous. And then when you turn around and use it to explain why there's a sun 180 degrees different than where it should be, or all the other reasons you use refraction, like I heard Dr. Zach say that's the reason the stars go backwards in the south. So just be careful. The globe is using it in a measured way and in a consistent way, not just willy-nilly because you need it in your model.
Right. And so it is time we all agree that refraction is a thing, and that we all try to start to study and understand, what does it do? What would it do? What should it do? Could it possibly explain this on a flat Earth? And later in this presentation, I'll show that it could not possibly explain this on a flat Earth. But first, I'm going to go to Canigou. I don't remember why I had this thrown in, but I did. This was given to me. The dark picture was given to me by a flat earther, claiming that the entire mountain was visible above the horizon, and that it should not be seen. So I looked into it. Because the sun is in the picture, we know that we know that the sun is about a half a degree in angular width. We can count the number of pixels across the sun, and we know how many pixels per degree this picture was taken at. So we can also count how many degrees and feet of height the mountain is obscured. And it turns out there was about 878 feet visible of a 9,000 foot mountain. So more than 8,000 feet were actually below the horizon line. So where did the rest of the mountain go? So this actually matches the globe much more closely than the flat Earth. And by the way, standard atmospheric refraction would cause a lift of a couple thousand feet or so, which would be just about right to lift that tip from just under the horizon to just above the horizon. But I wanted to know, what would it look like with the rest of the mountain? So I found a picture that was taken from the same angle but closer. See, I matched it up pretty good.
Yeah. Yeah, and it's getting ugly out there for flat earthers. If you've seen me do I'm observing rocket launches from 188 miles away, and we don't see the rocket until a good minute and 5 seconds till after it took off. Well, Dave Weiss has surmised, and people have now started copying this idea, that there's some sort of cloud horizon of 20,000 feet that reduces itself to the size of the horizon, and you have to wait till the rocket gets above that to see it. If that were true, though, of course, this picture's taken from 175 miles, and we see a 10,000 foot mountain. We see the top of it. So I thought that Dave Weiss had 20,000 foot clouds at 188 miles reduced down to the size of the horizon. So then that completely destroys any Canigou evidence. So it's all over the place now.
Yeah.
It's making up shit.
So I had actually drawn in this red line and this estimated sea level line before I found the other mountain, just based on the pixels and the pixels per degree and of the sun's width. Then I put in this picture, and you can see, it's kind of hard to see, but see where this red arrow is?
Mm-hmm.
This actually points to the sea level in this lower picture,
wow,
which is literally right where I calculated the sea level elevation of the mountain to be. So This is the mountain that's hidden below the horizon in the Canigou shot. So another one that matches the globe much more closely than the flat Earth one. A lot closer. Okay. So, some people are interested in what refraction does do. So now this is starting to study what does refraction do. So I went out on a cold, blustery day. The sun was not shining to create temperature gradient differences. It was windy and turbulent, and there was very little density gradient in the air, other than just the mild pressure lapse rate. And you can see I took a picture of this lighthouse that was 2.6 miles away. And I set up my crosshairs straight and level. You can see down here, VA is 0, 0, 0, vertical angle. And so my crosshairs are shooting straight out at eye level, and you can see this matches what we would expect on a globe. The shoreline is dropped below them just a little bit, and the building is appearing to about the same aspect ratio as close-up pictures of it. But then I went out on a hot, calm day the year before. Funny ordering there, but anyway. And the water was cold, but the air was hot and calm, and this allowed it to form a strong density gradient with cold, dense air close to the water, with decreasing density with elevation. And as you can see, this caused everything near the water to appear lifted up, and lifted up more than everything at the top. You can see the top of the building is also appearing lifted up, but the bottom is appearing even more lifted up. And you can see how much shorter it looks than the other picture. And you can see that the water here actually appears above eye level. So I'm above the water looking up at the water. Obviously, that's not possible on a globe if light is straight, and that's also not possible on a flat Earth. That would require a concave Earth.
Oh, don't say that, man. And all the concaves are going to show up. Great.
I know. But obviously it couldn't be concave, because then a different day when things appear their correct shape and size, then the water level is below eye level again. So this is an example of, on the left here, an example of a black swan day. And when you see all these, oil platforms seeing way too far, if you were to actually go out and objectively measure the elevation angle to that water line, that water surface, you would find it above eye level.
Wow.
Not flat, above eye level. So all this black swan so-called flat Earth evidence, actually, if they'd actually measured the elevation angle, would have disproved flat just as well. Would have disproved their method. Would have disproved the method of sighting close to the water when the water's colder than the air. So I have another example of this. Okay, in this case, I had the telescope.
You think the light,
hold on,
travel?
Sorry. You're good.
I had the telescope at the same location these 2 different days, a few days apart. And I waited for a ship to go by, and it's a shipping lane, so they go by the same place, all the time. And on this day, when that was hot, calm air over cold water, the water line on the ship appears an equivalent angle to 28 feet above eye level. So I'm above the water, looking upward at the water line on the side of this ship. But then on a different day, when the weather was cold and not cold and blustery, again, now this time the water line appears 20 feet below eye level. So it has a negative elevation angle, whereas on the hot, calm day, it had a positive elevation angle. So this is another example of a black swan day on the left, where the light is curving greater than the water, and you could actually see over the top of something, which I then illustrated with this. I was thinking, I wonder if I could set it up so my camera was below the top edge of this metal sign. It's a 18-inch wide, 24-inch high aluminum metal sign, and it's 300 feet offshore. and it marks the boundary of the public park there, because there's private beach next to the public beach. And so I set my theodolite telescope up 2 inches below the top edge of the sign. And then I waited for a ship to go by, and a ship and a barge went by. There's the barge. And as you can see, even though my telescope is below, physically below the top edge of the sign, and the top edge of the sign is physically above the water line on the ship, I can still see the water line on the ship over the top of the sign. So this is very good evidence, I think, that light can curve over what would be a physical obstruction. So you can see if this had been, a bulge of water instead of a metal sign, I could have seen that ship way too far. I could have seen it, what was physically behind the hill.
And the best air to do that over would be when you've got moist air right above water. Yep.
The temperature is the largest contributor to density gradients, because the temperature can vary so greatly from the surface of the water to 1 meter up to 2 meters up to 3 meters up, because water has such a greater thermal mass. It takes a lot longer for the temperature of the water to change compared to the temperature of the air. So this and this shows here that the top edge of the sign was 1 minute and 43 seconds of angle above eye level. So I was definitely looking up over the sign at the water. It seems very unintuitive, but if the light curves, that's exactly what would happen. All right, light curving. So this is by the way, am I running out of time, or am I
You're
okay?
Good. We're good.
Oh, good. All right, so this is a fish tank with, I put salt in the bottom and let it dissolve, but I did not stir it up, so it's more dense in the bottom and less dense in the top. And so I'm just shooting a laser in, and you can see that it's curving towards the more dense region. So anybody can very, very easily use sugar or salt to make a density gradient in water and prove that to themselves that light does curve towards the more dense region in that medium. I also did it without salt or sugar. I put icy cold water in the bottom half of the tank. You can see it's fogging up. And then I put a plastic sack over the top of that, and I poured in hot water on top, and then I slipped out the plastic sack. And because the hot water is less dense, it stayed floating on top of the cold water. And so I had this, and then in the middle, they mixed a little bit, and they formed a density gradient, not because of any added salt or sugar, just because of the difference in temperature of the water, nothing else, just the temperature difference. And so you can see the laser is curving downward, and you can see on the right here, I compressed it to show the curve. It's hard to get a strong curve because density of water doesn't change that much with temperature compared to adding sugar. Sugar or salt are much easier to do, but this did work. I did get a curve with just temperature. And so, of course, everyone says, well, we don't live in a fish tank. And we don't, in fact. So I did it in air.
Snow globe.
What's that?
So it's a snow globe.
Yeah. So I did it in air. This is actually with the fish tank, but with air in the fish tank, I created a density gradient, a temperature gradient inside the fish tank in air. So I had just like rock salt and ice cubes in the bottom. And then I had a piece of tin foil strung across the top with black paint and heat lamps shining on it. And then I had it all sealed up. And then, so this vertical fuzzy column here is the edge of the wall of the fish tank that's out of focus because it's closer to the camera. The camera is zoomed in on the building across the street. And this area of blue roofing through the left here is looking at the roof through the air in the fish tank. And then to the right here is looking at the roof not through the fish tank. So I have a view of the roof both through and not through, or through and not through the fish tank. And you can see the view through the fish tank has lifted up. Mm-hmm. Now I'm not looking through water. I'm not looking through salt or sugar. This is just air, but it has a temperature gradient. and that caused the roof to get lifted up. So this demonstrates that even air temperature gradient causes things to appear lifted up. And I had a little 12-volt computer fan in there, which I could turn on remotely. And when I turned the fan on, that would mix up the gradient, and then this roof line would go straight again. And then when I shut the fan off, then the gradient would reform, and this roof line would lift up again. So
I've never seen anybody do that.
So I think, and by the way, this is actually just a screenshot from a video. I have the whole video. It's all available on my YouTube.
Okay.
Which I believe you probably linked in the description.
I did. It's linked. You can just look up Ask Jesse. Oh, wait.
Yes.
Is that what it is? Ask Jesse?
From Jesse.
From Jesse. I was going to say. From Jesse.
Like
My bad.
Anyway, so I think this shows with a very reasonable level of confidence that light does bend towards the more dense region, and that a bottom heavy density gradient makes things look higher, including through air. So I think this is very good support for my theory that things like this are caused by a bottom heavy density gradient, by cold water underneath hot air.
And so if somebody could do that themselves, right? They just get a fish tank, they can put ice at the bottom of it or something. Then you basically have the air above it, and then you have something on the top to kind of keep it within.
You put a lid on top, and you get the lid hot.
Right.
So you create as strong of a temperature gradient as you can, because you're trying to do this over a couple feet.
Have you ever thought, what if you heated the air too? You could do that with like an air gun or heat gun. I mean, might be something to try.
Yeah, you could.
Just to see it move like that, I might try it myself because I've got a heat gun. Because I'm assuming that's going to move it quite a bit as well.
Yeah. Somehow though, you have to keep the upper column heated while letting the lower part remain cool. And if there's too much wind, you'll just mix it all up.
Right. So some ideas for people.
You might be able to get away with a little bit of a hot air flow, which I will show in a bit on something else.
Okay.
So one question that's been posed to me is, well, laser light is different than sunlight, and sunlight does not reflect like laser light does in a fish tank. So I tested that too. And I have set up a fish tank here under a temporary covering on a sunny day, and I have a slotted piece of cardboard with sunlight streaming through the slots in the cardboard coming in from the left. So you can see down here where the gradient is the strongest, the sunlight is curving down. And then I have a laser coming in from the right here along this ray of sunlight, and you can see that they pretty much refract just the same in the same medium, which they should, because sunlight includes 532 nanometers as well as all the others, right?
Right.
So sunlight does refract just like laser light does.
Excellent.
Okay, so many people have asked me, can refraction cause something curved to appear flat? The answer is yes. And to demonstrate that, I've taken this piece of aluminum metal, I've put 3 eyelets on it, and it is physically curved. And again, these are screenshots from videos that show everything in detail. So just search my YouTube for the word refraction, and you'll get all these. So when we fill this, or when we look through this from the end, look at what we get. That curved beam now looks flat, and we're looking right through the center of all of those eyelets. Let me go back. I'll show you. It is definitely curved. See, if you drew a straight line along here, this center eyelet would be way above the 2 end eyelets. You couldn't line them all up. But when you look through it, they all appear to line up because, I thought I had a follow-up picture for that. Because the light is curving. The light is curving. I actually bent the beam to match the curve rate of the laser beam the night before. So that's how I knew that the laser beam was curving equal to the gradient, to the refractive curve. And in the video, I actually shine the laser beam through all 3 of these eyelets. So there is an example of a stable density gradient refraction causing something curved to look flat.
You'd love to be in a world where this would be enough for people, you know?
Yeah.
That we would recognize things and we're like, oh, okay, that's been shown now, and now we move forward with this new knowledge and we build upon it. Not so in the world that I've been a part of for 10 years.
Yeah, it's been very interesting for me too. All right, so you were talking about blowing with a hot air gun. This is, on the right here is my bedroom, and just off screen to the right is my heat pump blowing hot air up at the ceiling. You can see kind of this diagonal air path where it's hitting the wall, and it hits the ceiling, it comes over, it hits the wall, it circulates down, it goes along my bed, and then the hot air is actually circulating up here. And even though it puts out pretty good wind, because the cold air on the floor is so much more dense, it stays down there. It's not even mixing that up. So I thought that was interesting. So you might actually be able to blow in hot air at the top horizontally and have it not mix very much with the cold air on the bottom. So it's worth a try.
Yeah.
So on the left is just looking down my hallway. You can see that it's hot at the top, cold at the bottom, and that's just due to the fact that the air forms a gradient. And the lighter, hotter air rises to the top, and the cold air is at the bottom. When my heater comes on, the hot air just goes up to the ceiling, and it stays up there.
So if you were looking at something far away in that hallway, you would expect to see the item appear higher. If you're looking down that hallway...
Absolutely.
Yeah.
Absolutely. At 40 feet, it wouldn't be much.
You know what I mean? Much further down,
yes.
Yeah.
Yes, but absolutely. That is correct. And here's in my kitchen. There's my reflection in the kitchen window with the thermal camera again. And you can see it's right cold on the floor, and the further up you go, the warmer it gets. Air just has a very strong tenacity to maintain that gradient because it is so much more dense when it's cold. So, you know, when people ask, well, what are the chances of a gradient, you know, existing, you know, many days out of a month over a lake? Well, if the lake is colder than the air,
right,
that is what's going to be, you know, it likes that. Okay, so now that we understand a little bit about that stuff, here's my method for measuring drop over distance. Basically, if I know my height above sea level, and there's mountains or buildings at any distance that are also measured relative to sea level, and I know how high they are, I can measure the angle to them, and I know the distance to them, so I can calculate the delta height using the arctangent of the rise over the run. And so I'm basically using mountains and buildings as really tall surveyor's rods. And I can measure the relative height difference, and if the sea level is flat, I'll get one result. If the sea level is dropping off curved, I will get a different result. And I get the different result as if sea level is dropping off curved.
We have in the chat, somebody saying, I've been here 10 minutes and I can't tell what's being sold here. So what's being shown is that there is a gradient that's causing things to be seen higher or lower than they should be. He showed examples of both, really. And now we're looking at what happens with a temperature gradient of cold at the bottom and heat at the top. And now he's just showing there in the next slide that how he's able to figure out when he has two of the three things, the third thing. What do you call it? Delta height? What did you say it's called?
Yeah, delta height.
Okay.
Because I don't really care how high I am above the sea level.
Right.
But what I care is the difference in height between my vantage point and my target vantage point, and what angle I get to that. Does it match what I would get if I and it were both on a flat baseline, or does it match what I and it get are if it is on a curved, if we're on a curved baseline?
Right. It's getting kind of embarrassing for me as well to see this over and over again now and just realize that why it is that flat Earth is still around. It's because they refuse to hear this. They won't listen. And I know that I was one of them. You know, there is a medical, I don't know if it's a medical condition, what it's called, a mental condition, where you just, in order to protect your belief, you start feeling very grandiose, and then your mind stops listening to detractors or people saying something different than what you believe. And the only thing you hear is other people repeating the same thing that you believe. And you don't even look into it. You don't even double check it. You just assume because you're a good person and you're looking into things and you got it right, that they're a good person and they're getting it right. And then you remove yourself from that group and now you see that everybody's just a liar. So it's a sad state of affairs because, and I've seen people, they keep changing the goalposts just for no reason. I mean, start with Dave Weiss saying that, a 24-hour sun in the south would prove a globe. We go down there and show a 24-hour sun in the south. No, now it doesn't matter. And it was faked with a laser in the sky or something. So there's one thing after another. Flat earthers say that we don't measure curve. The earth is measured flat. However, we have people that show you that it's measured curve. Now, despite what Jesse shows you, he'll shows himself measuring curve. Other people will show you the same thing. You'll just continue to repeat the same line because that's the only way flat earth can exist. You have to continue to lie and say, you may not even know you're lying. You just believe that the earth's measured flat. It always is measured flat. We measure flat below our feet, even though we're showing you that isn't the case. So why is it that, these things come up? First, that one, there's the, what was the one that Steve Falconer said, right? Oh, look at these two locations. That doesn't work on a flat earth and doesn't work on a globe. However, I just showed that it does work on a globe, which leaves that it doesn't work on a flat earth, which tells you which one is true, but people can't figure that out. Flatzoid says that the South Celestial Pole would prove the globe. We go down and show the South Celestial Pole. He changes it. Now it doesn't matter, and we're idiots or something. So it's just one, no matter which flat earther you go to, they've given you some reason why the earth is not a globe. Then when that's shown to be incorrect, they don't ever make amends for it or say sorry or apologize. Do you think Steve's going to apologize for everything he said about me or no? You think he'll double down on retardation and continue he'll just skip past it because no flat earther will hold him accountable? It's pretty sad. People, the South Pole doesn't exist on flat earth. So does anybody talk about it? Do you see anybody in flat earth working on where the South Pole is? They literally don't care. They literally don't care. They'll just say it's a ceremonial place. Well, where is it? Where is it at? Where's the location? Oh, we don't talk about that. Let's go to tomorrow and keep talking flat earth and pretend like we're winning. It's pretty embarrassing.
Must be a secret ceremony.
I guess. Jeez, not including me.
Anyway, some people have, a lot of times the flat earthers do bring up the question of refraction. They say, well, you did it with refraction. You applied the globe refraction, and that's why your flat earth measurements looked like a globe. So this shows that the red dots are raw measured depth. No corrections whatsoever. The blue line is the globe predicted curve of 8 inches per mile squared, probably. That's what I use, which is pretty close out to 100 miles. Very close to out to 100 miles.
Right.
So it's like, even without refraction, we still have
pretty close.
Something that's not flat.
Not even close.
Even if it's a 7/6 globe, it's still a globe. It's still not flat. But we know from the demonstrations we did with the temperature and density gradients that there has to be some refractive lift. We might not all agree on how much it should be, but we anyone who can do some simple tests at home has to know that there has to be some refractive lift. It can't be refractive sink. It has to be refractive lift, and it has to be non-zero.
Can I show that Melodome video? Just a quick second.
Oh, yeah.
Just show that. Maybe I've got it here. Let's just watch. This is just something that, after Z said there is no evidence of things being pulled from behind anybody's got any edges, then we've got Melodome here.
See that little blue spot at the horizon? That is a thumbtack that is on the back side of this ball right here. Okay?
So that thumbtack is below the height of the ball, meaning that you should not be able to see it from the other side at all. However, it is seen because he just put a lens there. Now, again, flat earthers will cry foul and say, but you have a lens there, you put a lens there. But they didn't cry foul when that's the only way that things could be explained by Rob Skiba, by putting a lens there. And then he found an atmospheric scientist who said, yes, the atmosphere acts as a lens. That's what it does.
Yep.
Just around the curve, we have this lens that is from Rob Skiba, right? You can even see the thumbtack a little bit right there, right?
Now watch what happens.
See it? When you take it off, goes away. Put it back, you can see it. Come back here to my level camera. Turn this bad boy back on. Boom. All right, so you see the little blue thumbtack. Again, let me come back over here.
This explains so much too, like the
Just to show you. Thumbtacks on the back side, right? Thumbtacks on the back side. You can see it here. Now lift the lens. Gone.
So you got that plus, if you remember the Grotto 1 experiment that always Dave Weiss brings up that shows that those lights are all seen on the horizon at the same height. And he says, well, why aren't they way up in the sky? Why is it putting everything right at the horizon line? Well, think about what you're saying. That you're seeing too far. You're seeing the ground behind the curve. So, of course, it's going to lift up to where? To your line of sight, to the tangent. How could it go higher than that? It wouldn't go up into the sky. It's just going to be up. You're just seeing further on the curve, but it's lifted up. So that's why you see all those lights that are 5, 7, 9, and 12 miles away all look like they're even. And Melodome's working on, I told him to get colored thumbtacks. It's a little harder because this is obviously, if you put one thumbtack behind another, that is the equivalent on a globe of hundreds of miles, right? Whereas when you're really just talking about 5, 7, 9 miles shown in that example. All right, go ahead. Sorry.
Yeah, no, yeah, it is hard to do scale models with such detail on a small scale model like that. But yes, now there is a condition that does cause bottom-up obstruction and something to appear lower, not higher, and that is when your line of sight is very close to a surface that is hotter than the air, like a road mirage. But that's not a stable condition because obviously the hotter air rises. So it can only exist close to a hot surface because as soon as the hot air rises, cold air falls in and gets reheated and rises. So it's this constant turbulence, and
which is really the cause of wind, right? I mean, wind
ultimately, ultimately, yeah. So, but that argument does not apply when your line of sight is high above the surface, and it does not apply day in and day out because it has to be that condition when the surface is hotter than the air, which is simply not all the time. And in my region, almost never. I got cold water where I come from. Anyway, so this is the difference between uncorrected angle measurements, optical angle measurements, and earth curve, geometric earth curve predicted. If we apply the single formula of 1 degree of lift per 932 miles, the same formula to every point, you can look how closely they line up. So it's not like we're, fudging each point individually. The same formula for standard atmospheric refraction brings all of them very close to the predicted. Oh, okay. So this is a little bit of a new topic. So this is something I did. This was actually Dan the Waterman's idea, and will always be grateful to him for this idea. He was going to do it with a truck on the salt flats, but I don't have salt flats, and I needed to do it by myself because I didn't have anyone to help me. So I went out to this bluff that's the ground's about 53 feet above the water, and I waited for a ship to come along this shipping lane. And pretty soon, the Overseas Boston came by, an oil tanker or something. I think that's an oil tanker. And so I had my theodolite set up. There it is. And I measured the elevation angle to the top of this blue shroud that covers the smokestacks, because that was an easy target that I could easily distinguish, so I could shoot the elevation angle to the same point on the ship every time, which is about 100 feet above the ground, or above the water. So these red lines represent all the angles that I shot elevation angles at as the ship traveled along this nearly straight line. And here's my data. And this spreadsheet is not on Google Sheets because I did it on a offline sheet program, but I'm glad to share it in whatever format. And as you can see, using the arctangent times of the angle times the distance, this blue line is what I calculated for the relative elevation of the top of the ship. So at first, it started out 20 feet above me, then 30 feet above me as it got to the middle of its run, and then almost 40 feet above me, and then it started going back down, and ultimately more than 10 feet below me. And the blue line has no correction for atmospheric refraction or anything. It's just the raw data. But if that ship had been sailing on a flat surface, I should have measured its height to be the same, because the height of the ship isn't going to change 40 feet while it sails along. And it wasn't the tides either, because the tides don't change nearly 40 feet in this area. The red line, of course, is just the geometric predicted globe Earth curve. So you can see what the difference is between kind of the effect that refraction has. And you can see the effect of refraction becomes greater as the ship gets farther and your line of sight is getting closer to the water, because the water bulges up. So when people say, well, there's no left to right curve, there is. All you got to do is measure for it. Okay, this one I did from Mount Scott in Crater Lake, Oregon. And the expected angle was 0.542 degrees above eye level. The measured angle was negative 0.10681 degrees, which equates to, again, about the missing 6-some-odd thousand feet that the globe would predict. In fact, if you work all the math, which I'm not going to bore you with, my measurement was within like 18 feet of the globe prediction at 105 miles distance. So how did that happen on a flat Earth, right? Just some weird air weather conditions that just happened to match the globe Earth within 18 feet at 105 miles. I got to parade my incredulity one of these days. Okay, some have asked whether theodolites match water tube levels. The answer is yes, and here I show it. So on the left, I have set up a water tube level with the near and the far water tubes ends about 10 feet apart. And I've also set up a theodolite, and you can see they are very close. Because people told me that my theodolite must have had NASA glass in it or something. So I used a good old tried and true water tube level. Here's a diagram of that. I had it set up on a hill. I sighted across it to the building. But somehow, the building that was 180 feet above me appeared below eye level. So I asked people, what path do you think the light took? Did it take a straight path, a curved path this way, or a curved path like number C here? Obviously, the only answer is number C, because that's the only way the light would be blocked by the water tube level. But then that requires it to be curving towards the less dense region, not the more dense region, which is the opposite of what we know about refraction. Unless, of course, the water were very hot and somehow there were a consistent day in and day out, year after year, top heavy gradient along these 21 miles, which I say is implausible. Okay, then these were just a few things that I had for Q&A. One of the cool things, I'm basically done here.
Okay.
So you can stop me if I'm out of time.
No, we can go ahead. I'll check if there's any super chats or any questions.
Oh, cool. So this is interesting. A flat earther, BMLSB69, who actually, I believe, was the first one to go out and get the Black Swan oil platform pictures, in in one of his videos that I believe is still on his website, the video code is, here's the URLs here in the frame. You can pause it and copy those down.
Wait, hold on. We're in the way. Let me move your picture real quick. Stay right there for a second. Just so people can see that. Go ahead and screen cap now. Oops, back down to where you were. There you go. Just hold that for a second. Okay, now you go ahead.
Okay. Anyway, in his video, and these are screenshots from his video, he says, for 3 months, I went to the same exact spot as many times as possible to test this. Almost every day within the 3 months, Grace and Gale was hidden behind the ocean horizon. That's his words. That's BM LSB's exact words. And you can see the first one is at 10 miles out, and he was 76 feet high in his observer location. So if you do the math, the globe horizon would be about 10 miles out. So it would be on a globe sitting right at the horizon, which is where it appears. See, the water comes right up to it, but then beyond it, you don't see water. The next two, and these are the conditions that he said he normally saw. He said only a few times did he see them all visible. And they're in his video, and you can watch the videos. But here, Grace is 20 miles out. So now there's a lot of hidden height. The helipad is supposed to be 121 feet off the water, and the globe Earth hidden predicted is 58 feet. So looks to me like about half of it is hidden, which matches the globe. And then this is Gale. I was unable to get a claimed height, a height for the helipad, but the globe Earth hidden would be 138 or 137 feet, and at 25 miles out, which looks very reasonable, just a little bit of the top is showing. So
people need to recognize that what's happening here is you're being lied to. And it's embarrassing to see people in the chat that don't see they're being lied to and they can't grasp it. Even though I'm telling you, you won't go check up on these things. Why does Nathan Oakley always tell you that if we live on a sphere of radius 3959, then the horizon must be no more than 1.22 times the square foot of the observer height in feet? The problem with that, of course, is that so that's just a statement in and of itself. And then they say, and then we go observe that it's higher, and therefore the Earth cannot be a sphere. Okay, great. If that statement was left just as is, maybe you have a point. The problem with it is that if we live on a sphere with a radius of 3959 and there is refraction, then you can keep going the story, and then you have a problem, right? Because then it's not that the horizon will be no more than 1 point, because we've just seen, Jesse's proven it, that the actual horizon rises above your eye line, okay? Or above where your eye line of the camera is. So that means that you do see further. And now we just found out from Bo himself that this is a rare occurrence where he's actually able to see all the platforms, which means that's not a normal thing. It's a rare happening, which means, is that a black swan when something pops up and you see? No, it's the opposite. So it just means that we can't take that one observation and take anything from it because it's abnormal. But go ahead, Jesse.
All right. Now, you said it very well. And then when you look at the ones where you can see way too far, a lot of times, not always, but a lot of times the booms are like all bent up. So there's like clearly gobs of refraction going on. I don't think I have one of those in my slideshow, but okay. This is a demonstration that I did of the water blocking things. In this case, the observer eye was about 100 feet high, and I picked out a place on the far shore, 20 miles away, that was also about 40 or more feet above the water level. And I've put a little orange box around it. Then I dropped down to here. Now as an observer, I'm 40 feet above sea level. And look, this area that I could see that's about 40 feet above sea level is obscured by the water line. So if there was a guy with a laser inside that box, 40 feet above the water, and I'm 40 feet above the water, I could not see his laser, even though on a flat Earth, the laser should come from him to me as a straight line 40 feet above the water, right?
For sure.
Oh, just if anyone had questions about lenses.
Let me see. We got Fepe the Penguin says, shout out to Ace McLeod. Wow, that's a thing from the past. That's hilarious.
Yep.
Ken P gifted 1 membership. Thank you very much, Ken. Dave's Waffle House gave 99 cents. Thank you very much. And we have Nominal. Thank you for 22 months. He says, do these measurements factor in the difference in the pitch of the mountains?
The pitch of the mountain.
Do these measurements factor in the difference in the pitch of the mountains? So again, I think that the only thing he showed was 75 miles away, and it would only tilt or whatever 1 degree in 69 miles. So if you think of something standing straight up versus tilted 1 degree, I don't think it's going to make a difference in the height much. I mean, look at that.
Oh, is he talking about the deflection or the change of vertical?
I guess that would be very tiny, wouldn't it?
Oh, that would be extremely tiny, because even if it leaned away from you, even if it was 69 miles and it leaned away from you 1 degree, because you're looking at it from the side, that's not going to change the elevation angle to the top much, because that's right at the top of the curve. It's
like feet, right? I mean, not a lot at all.
Maybe inches.
Okay. Yeah.
Yeah.
Makes sense. Yeah. So I think that's what he was asking there, I believe. Yeah, it's a problem that I think many people have had, that the idea of, oh, why don't we see things leaning away? I mean, think about that. In 69 miles, which you rarely would ever see that far, you have 1 degree of change, which is just not going to be noticeable by anybody's eye, period.
Yeah.
So you wouldn't see that. Let me see if there's any other questions in chat. If you at me real quick, I will ask Jesse, but you have about a couple minutes. Go ahead. Live chat. Make sure you at Jeranism just so I can see it and I don't miss it. See if there's anything in here. Give up flirfs, it's over. Man, if that's a dream world. A dream world is where we wake up tomorrow and we can actually worry about real conspiracies and we can move on and really talk about things. And we forget about this dark period of 10 years where everyone lost their mind a little bit and went a little wacko. Now here's somebody says, concave Earth. We are inside of a hollow torus plasma confinement field. Okay. I'm sure there's plenty of evidence of that. You'll get it to me later.
No, he can't. It's confined.
No one can prove Earth is a globe when the globe has been debunked already for thousands of years. I mean, Tony Flat Earther, that's a great statement. However, usually something like that would be backed by evidence of said debunking, and spinny, watery ball in space is not a debunking of the globe, unfortunately. Let's see if we got anybody else here. They're all fake and photoshopped. What is? Oh, pictures of the Earth? Damn, all those measurements that show globe. It's a lot. It's concave by Lawrence Miller. CatGPT says, do you have a timestamp? Because it's over 1 hour and 10 minutes. I don't know what that is. Sorry. Understand why you're frustrated. I understand why they're frustrated too. I wish I could just, sit and hug each flat earther for, well, not all of them. Some of them probably don't smell great, but some probably smell decent. Where I'd at least be able to hug them for 5 minutes and just say, hey, let's talk about it. Let's get it out that, this is what happens when you go too far in believing your own bullshit, right? It's just like what they say. Some people who have bad breath don't actually smell it because it's underneath their nose all the time. And so they just get used to it. It's kind of the same thing. And then when you step out and you look back in, you're like, holy shit, I've never seen so much. Flat earthers at this point to me like children. They are yelling and screaming and claiming that they have evidence and claiming that they have facts, and other people are idiots and morons. And they don't have any of that. So they actually are just showing themselves to be exactly what they're claiming the other people are. Same thing with saying like, oh, you guys are indoctrinated, but yet all flat earthers believe and repeat the same thing that they heard from other flat earthers, which is the definition of being indoctrinated. You're not following up on any of these things. You don't know, like none of you can explain Steve Falconer's video at all. It's just numbers and math and a whole bunch of nonsense. And everybody who watches it for 2 minutes then comes and yells at me and says, why don't you go debunk him? But you haven't watched it yourself enough, or else you would know it's been debunked. So it's pretty sad to see that from this. You know why it's so sad is it's embarrassing. It's embarrassing to know that I was part of that. And it's embarrassing to think that these people thought of me the way I think of flat earthers now, which is just, hey, we're showing you evidence of these things. So let's move forward. Let's get past it. Now I'm looking at the flat earth like, I don't think it'll ever go anywhere. It's just going to continue to be people who, make a lot of noise and scream and yell, and it doesn't surprise me that people have dismissed you or laughed at you or done the things that they've done for 10 years. It's pretty sad to see from the outside. You should take it, if there's any way that you could take a week off and try and approach it like, okay, I'm going to pretend like I'm a globe believer. I'm going to, whatever you can do to try and get yourself out of that flat earth mindset for a second. And then you'll realize, I mean, I watch Dave Weiss's presentations now and I want to throw up. I want to throw up. He said the other day that all globes say that they're just for entertainment purposes only. And that they're doing that so they're not sued because of what would happen if somebody used a globe for navigation, which is just ridiculous. It's just ridiculous. And I was into, what's that place called? Hobby Lobby? Probably not more than a month ago. And I just happened to pass by the globe section and was looking at the bottom, and none of them said for entertainment purposes or not for real purposes or is a toy only. So I think that probably was like stuck onto one globe at one time. And now it's repeated by everybody as if it happens all the time. I don't even think you could find a globe that says that, to be honest with you. But anyway,
mine does not.
Yours does not. Yeah, I couldn't find one at the whole. I should go back and do that just because he just said it in the show yesterday, and it's certainly not for the reasons of the globe company's afraid of getting sued or something stupid. It's just not that. And stop saying that the globe model doesn't have a model. It's hilarious to hear.
Like an airliner pilot is gonna go get a cheap toy globe,
right?
And try to fly from it.
So just the problem is that now I'm seeing that these guys are all lying to you. Now, whether or not they know they're lying, that's a difficult thing to say because I can tell you I did not lie to you when I was a flat earther. However, I gave you false information. I gave you things that were untrue. I told you things that were fact that are not. Now, again, if you describe a lie as the person has to know what they're saying is untrue, in that case, I wasn't lying. But if a lie is simply saying something that's untrue, then I lied a lot. So it just depends on which definition of lie you use. If we're talking about they have to know that they're lying, I'm not sure a lot of flat earthers know. If you're just if you have to just say something untrue, then every flat earther lies and lies daily. So Dave is definitely lying, says Ken P. It certainly seems, I mean, when you start saying maybe there's a dome above their heads and maybe there's a plasma screen, God's screen, as we said the other day. So God's screen in the sky is how they projected a plasma ball onto the ceiling. And I just thought it was the sun because I'm retarded, I guess. I don't know.
Well, since we got the maybe running so good, maybe Earth is a globe.
Maybe. It could be. It could be. Well, if you guys go down south, you will realize like I did. I mean, people think like, oh, you just saw one thing and changed your mind. No. The south unfolds everything because number one, it's the opposite of the north. How does that work on a flat earth? It doesn't. It only works on a sphere. South celestial pole, the South Pole. Both places can't even exist on a flat earth, but yet they both exist. How about the sun setting? How about this one? This one's so simple for people. Just grasp this for a second. If you're in the north, the sun sets for you every day, left to right. You look west. Don't come and tell me, Jaron, left and right are relative. I'm saying look west. By saying that now, left and right are not relative anymore. Okay? Look west and the sun sets left to right for everybody in the north. Go to the south and the sun sets right to left for everybody in the south. That's all you need. Case closed. Doesn't work on a flat earth. Will never work on a flat earth. There's no explanation for it. There's no reason why just being on one side of the equator versus the other would cause an entire sun to switch directions. But it's not actually the sun switching directions. It's because you're on a curved earth. And I hate to tell you guys this. Are you ready? You're going to hate this. You're going to hate this. Are you ready? The earth is spinning. The earth is spinning, causing the day and night cycles. Hate to tell you. Anyway, you'll figure that out soon enough. I'm just taking it slow. Take it a little slow. Take it a little slow. Globe doesn't have a model, but Flat Earth has a bucket of Kentucky Fried Chicken. Dave Weiss. Yeah, that's somebody put together just a what do you call it? A collage of just Dave Weiss nonsense. Because I did hear that one. He says, you know, a globe Earth model can't put a ship upside down on the bottom of it and can't hold water on the outside of a globe. But if I get a bucket of chicken, you can put a boat inside of gravy inside the bucket and you can contain air in there. And therefore, the Kentucky Fried Chicken bucket is a better model of the Earth than a globe. This is the level of nonsense coming out of the Flat Earth camp. Ridiculous.
Sounds like Dave's favorite animal is a chicken and his favorite person is Colonel Sanders.
Might be. Might be. I know people, I don't think that people are very happy with me. That's right. Hey, somebody's got to tell you, because if I didn't tell you, then nobody would. And nobody would have came back from Antarctica and even switched their mind if it wasn't for me. So That's a scary thought because you need to be able to recognize what the world is telling you. This is what I've gotten to this point now. You couldn't lie to people about where they live. It's not even possible if they can make observations. As long as not everybody's blind, then you could. If everybody's blind, you could probably lie about where we live. But if people have eyes and they can make observations, then it becomes impossible to lie about where you live because you have to match observations with the place that they say that you live. Well, the place that they say we live only matches if the place that we live is a sphere. As soon as you put it anywhere else, the sky no longer makes sense. You can't explain the sun. You can't explain the stars. You can't explain anything. So that tells you where we live. And it's unfortunate because the only reason that you can actually believe that we live somewhere that we don't is if you lie to yourself. So for 10 years, I lied to myself to the point where I thought we lived somewhere else than we live. And I thought that somebody was able to lie to me about it. Now I'm at the point where I'm like, they can't lie to me about where I live. The sun tells me where I live. The stars tell me where I live. And so that's pretty much all you need. And then the ground does. If you're talking about the ground, you can just go, well, still looking at the stars for reference, but go 69 miles north or south. And every time you do, you'll adjust the North Star by 1 degree. And then do 360 times 69 miles and you get the circumference of the Earth. So it's right there in front of you. I can't help you because you're going to need to figure it out on your own. Nobody probably could have told me that the Earth was a sphere. I would have never listened. So maybe that's the problem, is that I'm just saying words that no flat earther will ever listen to. But I'm trying to, I don't know, maybe kick you in the balls so that you just have that moment where you're like, oh, and then right then you kind of think to yourself, oh, and then you realize you're on a globe, and then you're like, okay, now back to my balls. So we'll try that next time. Jaron, what do you think of outer space? I think it's outer and space. No, I don't know fully. I still have questions about some of it, but I mean, I guess that's all for me to figure out in time. The vacuum of space kind of idea is a little bit strange to me, but I get it. It's just, low pressure, high pressure goes low pressure. But yeah, I don't know. I've never been there, so I can't bring any back to test it. So for the most part, though, as far as when it comes to the Earth, the shape of it is pretty simple to surmise on your own. You don't even need any authority. Go down south, watch the sunset from Punta Arenas. It is so obvious. The sun dips down below the horizon for a couple hours, comes right back up in the southeast. It can't be anything other than the globe. How did it light Australia in the short amount of time that it dipped underneath the horizon? Well, it did because Australia is on the other side of the ball. So anyway, what else you got, Jesse, before we close it out?
That's about it, unless you wanted to skip around in a few short videos documenting my string project. Because remember, you had Kevin Samuel or Seven.
I do remember him, yes.
Yeah. I'm doing a project just like his. I was helping him a lot with his as well.
Show me.
With for ideas. And I gave you a link to my playlist in Telegram if you want to bring that up. And don't watch them all, but you could just like skip around just to kind of see what I'm doing.
Okay. Let me bring it over here.
All right, string test. So I've got.
So tell us what you're doing here. I'll bring it up for everyone to see. Where's this at over here? Display right.
Okay, I'm going to stop sharing so I can get a bigger picture of.
Sure, you should see it on the screen there now.
I do. Yep.
Okay.
Okay, so this is a measuring tensioner. A power measuring tensioner. So I've got these little rollers and everything. So I can tension this paracord by pulling on it, pulling it past the capstan. And I can measure the tension in pounds or kilograms on that scale as I tension it. So I'll be able to know exactly how hard I'm pulling on the string as I pull on it, as I winch it tight. So I'm going to wind it around that capstan and then put it through those clamshell grabber thing, and it's easier with one hand or with two hands, and I was holding the phone. So I redo that, but I built it out of an old wheelchair motor and things I got off eBay and stuff like that. So when I pull the string, it lifts that switch, which turns on the motor and helps me pull. So I can pull 90 pounds without too much effort. And so I think I've got a...
Are you an engineer by profession?
Mostly it's just a hobby. Sometimes I get a little gig, a paying gig, but mostly it's just a hobby. So you can see I can pull and the capstan turns on. If I want to release tension, I take it out of there and let it pay out. It's it's kind of like the capstans they use on ships and stuff. The hub is always turning whenever the switch is on, and when you pull, that tightens onto the capstan, and then it helps you pull. But if you let it slack, then it loosens and it slides off without the capstan having to reverse. So that's for tensioning my string. And I'm like winching up the lawnmower. You can skip forward a little there if you like.
Okay. How far?
Oh, there's the lawnmower coming. Okay. And now I skip forward a little more until you see the battery box. There's the battery box is driven by a bunch of lithium ions with cell protectors so they don't undercharge. Okay, that's about it for that video. So if you just hit the next arrow to go to the next one, that's the retrieval winder I built to retrieve the 6 kilometers of string out of the lake, hopefully once the test is done.
When are you going to do this?
I am hoping to do it this summer. I hoped to do it last summer, but I didn't quite get my ducks in a row, and then the weather went foul.
So you're trying to do the same thing that we've talked about before, right? That you're trying to take a spool of wire or thread or fishing line, whatever, and put it right above the water level. Right?
Yeah, buoyant string, or slightly buoyant string at the water surface.
Good.
At the ends, and then see if I can pull it tight enough that it cuts into the bulge like a...
How wide are you trying to do? How many miles wide?
About 3.7 miles long.
So that leaves a change of what about, so it'd be 6 feet of drop. So the middle is probably 2 feet.
28 inches would be the straight line sagittal depth.
Yeah.
So these are waterproof wireless charging walkie-talkies I modified. I took some FRS radios and I put some desiccant packs in there, and I put a wireless charging kit on the back so I can charge them without unsealing them. And then I weighed them so I know if they're taking on water, I can weigh them again, and I know. So they're permanent or semi-permanently sealed in there. So they're that's so that me and whoever helps me has communications for the project. But anyway, yeah, so the sagittal would be like 28 inches deep for a straight line.
Should be noticeable.
What's that?
I said it should be noticeable.
Yeah. Because the string is buoyant and I cannot pull it infinitely tight, the math says I should be able to pull it very roughly about 10 inches under the surface because it is floating string. Okay, that's all you need to see of this video.
Okay. You got travel clocks or something?
Oh, yeah. Okay, so I made 4 waterproof clocks. The glue is drying on all those. They're sealed in those vinyl envelopes that I sealed with pipe glue.
Nice.
PVC pipe glue. And they've got lithium batteries in them and on-off switches that I can add so I can turn them off to save the battery so I can turn them on when D-Day comes. Okay, you can go to the next one. Because I need to have synchronized clocks. Okay, so see, there's 2 cameras on a buoy, a styrofoam floaty thing with a ruler, you can see, and an LED light. And the whole thing is going to float and straddle the string, but let the string sink if the string wants to. So this is supposed to be in the middle. See, I'm feeding string through I'm just testing it in a barrel here.
Gotcha.
So the 2 cameras are just for redundancy. So the plan is to have 2 GoPros filming the string depth in the middle, and then a GoPro at each end filming the string depth at the end, all with a clock in view, each with a clock in view, and then also a camera filming the tension and the tensioning mechanism, which we saw first, so that and all the clocks will be lined up side by side before and after.
I'm excited about this one, man. This is a good test.
Yeah, I hope so. So that way we'll be able to know that the videos, all the separate video feeds get synchronized correctly, because they'll all have a synchronized clock in them.
That's awesome. This is a great comment here by Grave, who says, I found his model. The creator uses our rectangular map showing time zones and says we have personal domes that shows us what we see because we live in a VR world. So virtual reality. Can't you tell, Jesse? Look around.
I guess so. It doesn't seem very virtual to me.
Yeah, me neither. It seems pretty real, but some people say that it's the same difference, I guess. I don't know. I told somebody that the other day. I'm like, dude, this is not a simulation. Stop saying that. He's like, what? In a simulated game, some people, they have jobs, they go to work, I'm like, dude, if you think in a video game that people go to jobs and work, you don't understand how video games work.
Yeah.
The people in real life actually do go to those jobs, and they do actually do jobs. They actually do work. They're not simulated. Yeah.
Skip forward here a bit until it changes to a different scene.
Okay.
I'm just machining away. You'll see the spool winder going. There. Okay, right there.
This one.
So that is 6 kilometers of string on that spool right now.
And that's, you said, just slightly above buoyant?
Yep, it's just slightly buoyant. It has a net buoyancy of about 1 milligram per foot.
Okay, cool. That's kind of what I was thinking. Is it a monofilament? What kind of?
No, it's braided PE.
Okay.
So
wasn't too expensive then?
What's that?
It wasn't too expensive. It cost like $1,000 or less.
I got the cheap stuff from China. And it was like, I think it was like $400 or $500 or so. I don't remember. Yeah. Maybe it was 600. I could be. No, I think it was around $400 I spent on 6 kilometers of string. So you can see I made it so I could adjust the travel distance of my level winder.
Tony, flat earther, I mean, does it feel good? He said, glurfs are so gullible and ignorant. It's just frustrating because I just told you about the sun setting right to left in the south and setting left to right in the north. So who is gullible and ignorant if you just believe that means nothing? That the sun just goes around clockwise, but yet people on different sides of the equator see it going a different direction completely. So it sounds like somebody is pretty ignorant to me, but it's not the globe side. Go ahead.
All right. What's next on the video? What's the next video?
Let's see. That's this one. Let's go. Next one. You've got this thing.
Okay. So that's just I fixed up a 1968 Esca outboard to push my canoe. So it helped me pull the string out across the lake. That's all that is. You can
you got
skip that one.
Then this is a canoe outrigger pontoon.
Oh yeah, yeah. I built
your boat.
A foam and fiberglass resin and covered it with glass and resin, but it's foam board, and so it provides ballast and stability when I have my motor on the other side.
And where are you going to be doing the tests from?
Freshwater lake, which I'm not publicizing yet, just because I don't want
good idea
people, waiting out. I'm trying to make trouble. You know how that is.
Yes. Oh, believe me.
Oh, you do. You know better than anybody. Okay, this is just me testing the outrigger. That's just me working on the outrigger.
And we got one more update on it. The last update. So you have your boat ready. You've got your motor ready. You got your spool ready. What are you still waiting on?
I still need to make something that clamps onto that motor mount board and supports the spool while it spools out. Mm-hmm. And I still need to also do a endurance test on the motor where I get out in the lake and just run it wide open for an hour and see if it burns up.
Okay.
Because if it burns up and running wide open, then obviously I need to come up with a new motor. So that is the only 2 things that I think are left on my checklist. So
well, awesome. Look forward to that. Make sure you keep us up to date. If you want to come back and tell me when you're going to be getting closer, we could do another covering of it. But that's pretty much it for today. I hope you guys enjoyed that presentation. I think it was great at showing that things do actually loom up, and then also showing how we can measure curve, because every flat earther says that curve isn't measured. But this is kind of a symptom of flat earth, is that you just claim a bunch of things that cannot be done, and then when they are done or when they are shown, you just pretend like they're not. So imagine if that's your kind of setup for a situation, how would that person ever come to realize that they're wrong? So they make claims, they say this doesn't happen, you can't show this, you can't prove this doesn't work. Then you show those things are not correct, but they're not listening. So they, of course, go to the next day with the same ideas, and the next day, same ideas. And they never actually listen to any debunking information or acknowledge when they're told that they're wrong. So it's the same thing with Steve. Steve clearly has been shown to be wrong. with his stupid Scam-Arctica videos, which just do nothing but prove that the sun does go around in 24 hours for every base in Antarctica. He proved that well, which is impossible on a flat Earth. Then he shows something that he says can't happen because we can't have the sun rise somewhere west of somewhere east first, forgetting that we live on a globe. And when you look at the globe, you're like, oh shit, you can have things rise in the west before they rise in something in the east. And that's just a product of the globe. It's a feature of the globe that because you don't understand the globe, you're actually claiming that it debunks the globe when it actually proves it. So that's pretty sad to see this over and over again now. My hope for the flat Earth is it should end. It should be done tomorrow. It should be done yesterday. But I'll give it a day. I'll give you one more day to kind of say goodbye to your friends and delete your channels. And then tomorrow we go forward with no more flat Earth. No, I mean, that really is what should happen in a real world where people actually recognize what evidence is and what facts are and what truth is. And not just pretend that you can call me a shill and that's going to somehow solve all your problems. It's not. Hate to tell you. Calling me a shill is not going to change the shape of the Earth. Mark my words very carefully. Listen very carefully. You will never, at any point in time, in the future, wake up and the Earth be flat. Never. It will not happen in your children's future. It will not happen in your grandchildren's future. It will not happen in your great-grandchildren's future. So you've got in front of you and your family nothing but the globe Earth. And until you come to grips with that, you're going to be wasting hours, time, years. I wasted 10 years off something that is not true. That's upsetting because now you look back, you're like, okay, well, what did I really get done in that time? It's like you ran on a hamster wheel really, really, really fast. And then you got off 10 years later and realized, oh shit, I'm right where I was. Nothing different here. Now, have I learned some things? Have I grown intellectually? Have I learned about people and things like that? Yes, absolutely. But I feel bad for everyone that's still stuck in the flat Earth because you're not going to ever get anywhere. That's impossible to. How can you get somewhere? In order for the flat Earth to ever take over the globe, it would have to better explain reality, and yet it can't even explain the sun. Full stop. It can't explain sunrise, sunset. Full stop. It can't explain the south celestial pole, a south pole, the sun setting the wrong directions. We can go on and on and on and on. There's 1,000 things. And that's sad to realize now because I realize how hard it's going to be for those of you who are still flat earthers to get out. Because you're going to have to somehow, I had the observation. I got to see something that woke me up, that moved that mental block out of the way, kicked it through. Melodome had to see what he saw with the sun for 6 months to have it kick through. Not sure what Nick saw. I mean, Robbie, Patricia, Paul on the plane. By the way, this is also something I want to state that should tell you something, or maybe it tells you something, maybe it doesn't. If you think that for 1 second that myself or Melodome or Nick Havoc or Patricia or Paul or Robbie have doubted our decision for 1 second, you're wrong. There's not been 1 second that one of us has thought, could we have made the wrong choice? Is the Earth actually flat and we just don't realize it? Did we fall for some trickery at the globe and that's why we believe what we do? The answer is no, not for 1 second. And if that doesn't tell you something, well, then nothing will. That if I've been doing flat Earth for 10 years and I'm able to, on a dime, turn and say, oops, I was wrong, here's why. If you had any intelligence at all, you would listen to that person and listen to why. Because they might have some insight if they've been doing it for 10 years and they flipped. But instead, if you just call that person a shill, do you realize that that's the easiest way to stay locked in your beliefs forever? You're just going to stay, because anybody who defects, anybody who says, oh, I found the truth, oh, anybody who says I was wrong, you're just going to say shill. So you basically created a bubble for yourself where you can exist in some la magic land where we don't have to explain how things work. We don't have to explain anything. You go around saying things like, we can't tell the shape of the ground by looking at the lights in the sky, when you actually can. It's evidence. It's evidence of something that you're looking for. So just follow the evidence rather than dismiss it completely because it disproves you. That's the only reason you say that. Trust me, if looking in the sky proved the flat Earth, then everybody would be talking about it every day. So it just so happens because it proves the globe, now you don't want to talk about it. Now you want to say we can't do that. We can't look at that. So what's next? If we measure curve, you're going to say, well, we can't measure things with rulers to figure out the shape of the ground. You'll just make up some new saying and everybody will repeat it and it will be a bunch of boring stuff. Anyway, tell everybody one more time where they can find you, Jesse, and anything you want to close out with.
Okay, let's see. I guess I should give my Gmail or my YouTube link once here, huh?
Your YouTube link, yes, it's in the description as well. And it's just @from Jesse, Jesse.
Yeah, so
Yes, we can do that.
That's about the only place to find me. And I thank you so much for doing this. I enjoyed this a lot.
Yeah, it's good. Anytime you have something you want to present like that, I'm just trying to get the right information out to people that may be still searching for it. I have had quite a few emails from people that are not these creators, and they see what's happening, right? They're like, "Oh, I had to step away. You're right," and it scared me to see what these other creators are doing, because they are just doubling down and they are pretending as if nothing happened. That's the thing. They call it the failed final experiment, which is hilarious because it actually exposed one of the fatal flaws of flat Earth. There is no more pretending that it doesn't happen or something, and yet people want to. Go ahead.
Yep.
So here I'm putting it right above his name. It's from Jesse. Let's go with that. Right above his image there. So that's how you find him on YouTube. That's the channel. You can just do youtube.com/@from Jesse, and you will get there. You can do @Jeranism to find me, but you're already there, so you probably found that already. All right, I think that is it. Nothing else for you?
One thing is, I am working on, but I'm not ready yet. I am working on a demonstration to demonstrate why Mike Heffron's angles work on a globe just as well.
Gotcha.
They claim they don't work on a globe, but they do.
Well, and remind me on this one, because I'm a little bit confused. So they call it the celestial theodolite, right? And they think it proves the ground is level. But aren't they looking into the sky to get the shape of the ground?
Yeah, they are.
But I thought, I'm very confused now. Okay, so sometimes we can look in the sky when it proves the ground is flat, you're allowed to, but when it proves the ground is a sphere, then not allowed to. Is that correct?
Right.
Okay, just making sure. Make sure I understood that.
That's exactly it.
It's fun.
In fact, the method involves telling stellarium that it's on a mountain peak and turning off refraction and then reading the elevation angle to the star and claiming that is the true geometric direction, elevation angle to the star. The problem is if you put stellarium at the observer location at that exact same date and time, also with refraction correction turned off, it gives a different elevation angle because of the 1 degree per 69 miles. So, but you can't have two true angles that are different than each other unless Earth is a globe, right?
Right. Law of contradiction there too.
Yep.
All right. So that's good to know. So celestial theodolite people. Another strikeout. All right. I am going to head out, see if there's anything in the chat. Nope. Jaren is the new Red's Rhetoric. I'm way better looking than Red's Rhetoric. I'm not afraid to show my face. Anyway, I think that's it. What do we have coming up this week? Tomorrow, I've got a rocket launch. Let me make sure it's still happening. These things change like crazy, but I believe that it is still happening. So that'll be super early in the morning, but that's good because I'll be able to get home and get it uploaded and then do a video about it if everything's clear, which I don't really know if that's the case. Haven't been very lucky when I announce them early. Let me see here. If it's happening, they change these so often. So tomorrow is the Wednesday at... they changed the time. Okay, it looks like it won't be in the morning. So it's tomorrow at 3:11 p.m. I don't like that time slot. Man, go back to 6 a.m. All right, well, it looks like still happening tomorrow. I still would be able to come home and do that if it happens in that 3 to 6 time slot. But if you haven't seen those yet, check them out on my channel. Basically, I'm 188 miles away from Vandenberg, and I've recorded a couple launches so far. And when you sync them up, it ends up being that we're not seeing the rocket for over a minute in each case, which is crazy to think about if you really think about it. The Earth is flat, and the rocket takes off, and then a minute and 5 seconds later, then it appears from the horizon. Where is it for the minute and 5 seconds?
Maybe it's flying in circles like the jetliners do to waste time.
There's circling pattern. But that doesn't match this on-screen video. That's weird. Please, can you circle around? What do they call it? Go around. Can we just do a go around? That's what they keep telling them. Then they come back. My wife says it's in Vanish Land. By the way, she likes that. She says it lives in Vanish Land for the first minute and 5 seconds. I guess so. All right, we are out of here. Do I have any music to play on the way out of here? I guess I could play something as an exit. It is, I remind you, please do your own research. When you do, you'll never again believe that you can't tell the shape of the ground by looking at the lights in the sky, because guess what? You most certainly can. All right, till next time, guys. This has been Jeranism. I don't have a song. We'll play this one. Peace. Later, Jesse. Thanks.
Thank you.
F-U to the stress, to the grind, F you to the haters. Every time, F you to the drama, to the hype, F you to the mainstream, pushing lies, unplugged from the matrix. It's Friday night, unplugged with Mr. Honest, and sometimes right. F you to the left, to the right, and F you to the elite parasite. F you to the noise, F you to the fakes, F you to all you weak snowflakes. Friday unplugged, unfiltered and real. Are you offended? How you feel? F you to the sleep, F you to the woke, to the trolls in the chat, you're an effing joke. F you to the sleep, F you to the woke, to the trolls in the chat, you're an effing joke. This ain't a trap house, but your mind's getting drugged. Time for Jeranism, Friday unplugged. This ain't a trap house, but your mind's getting drugged. Time for Jeranism, Friday unplugged.